Beneath our feet, Earth is alive with hidden power, shaping continents, raising mountains, and sometimes unleashing cataclysmic force. The ground we walk on is not as solid as it seems. It is constantly shifting, driven by forces deep within the planet. The McDermott Caldera, straddling Nevada and Oregon, looks peaceful, but its past is written in fire and stone. What appears to be a quiet landscape hides a dramatic history of eruptions and transformation. Imagine a force so immense it scars the land, visible even from space. These marks are reminders of the planet's restless energy, etched across the surface for millennia. This is not fiction, it's our planet's own story. The evidence is all around us in the rocks, the valleys, and the mountains that rise from ancient eruptions. For millions of years, McDermott has slept, its violent history buried by time. Nature has reclaimed the land, softening its scars with life and growth. But Earth is never truly still. Even when all seems calm, the planet's inner workings continue, quietly shifting and changing the world above. Recent discoveries hint that this ancient giant is stirring, sending subtle signals to the surface. Scientists have detected faint tremors and unusual patterns, signs that something is happening deep below. What does it mean for a volcano to awaken? That question drives us to look closer. Each rock and mineral holds a clue, a piece of the puzzle waiting to be understood. The story of McDermott Caldera is not about doom, but discovery. It's a chance to learn more about our planet and how it works, to unlock secrets hidden beneath the surface. Science lets us peer into the planet's heart, piecing together clues from the past to understand the present. Through careful study, we can predict, prepare, and protect ourselves from what may come. The ground's subtle movements and faint tremors are messages from deep below. Each vibration is a whisper from the earth, telling us its story. Our challenge is to read them, to translate the language of the earth. By decoding these signals, we gain insight into the forces that shape our world. This journey reminds us, we live on a powerful, dynamic world. The planet is always changing, and we are part of its ongoing story. We are explorers, always asking why, always seeking to understand the forces that shape our home. Curiosity drives us forward, inspiring new discoveries every day. The story of McDermott Caldera is our story, science in action, curiosity in motion. As we study this hidden giant, we learn more about ourselves and the incredible planet we call home. To understand McDermott, we must travel back 16 million years. Picture a massive volcano, not a cone, but a vast blister of magma pushing upward. When pressure became too great, it exploded in a super eruption, emptying its magma chamber. The ground above collapsed, forming a giant sunken basin, a caldera. McDermott Caldera stretches nearly 28 miles across, a silent monument to Earth's fury. The eruption blanketed thousands of square miles in ash and rock, leaving behind layers scientists read like a history book. This event was part of the Yellowstone Hotspot Track, a chain of ancient calderas across the West. McDermott is one of the oldest and largest links in that chain. Today's quiet landscape hides the aftermath of a cosmic-scale event. The question now is the energy that once fueled this giant gathering again, deep beneath our feet. For many years, McDermott Caldera was believed to be extinct. Its volcanic heart thought to be cold and lifeless, a relic of ancient eruptions. But science thrives on surprises, and nature often rewrites the stories we think we know. Recently, scientists detected a subtle but persistent rise in the ground at McDermott, just a few inches over several years. In the world of geology, even these tiny movements can signal something significant happening deep below. This gentle swelling suggests that magma is slowly accumulating far beneath the surface, pushing the earth upward and reawakening the caldera's ancient plumbing. Alongside this, swarms of tiny deep earthquakes have been detected, too weak for people to feel, but unmistakable signals that magma is on the move. These microquakes occur as molten rock cracks the brittle crust, sending out seismic whispers that only sensitive instruments can catch. Together, the rising ground and deep tremors suggest McDermott is not extinct but merely dormant, quiet but not dead. A new batch of magma is gathering miles beneath the surface, re-energizing the ancient volcanic system and hinting at the caldera's hidden vitality. This doesn't mean an eruption is imminent. These underground processes can unfold over thousands, even tens of thousands of years. But it does mean McDermott has re-entered the land of the living, its story far from over. For scientists, it's a place of immense fascination, a rare opportunity to watch a sleeping giant begin to stir, and to gather clues about how volcanoes awaken from their slumber. Each new clue, each tremor and shift helps us piece together the mysteries of volcanic life cycles. The story is just beginning, and the world is watching closely, eager to see what will happen next. McDermott's subtle signals are a powerful reminder. Earth's energy is never truly gone, only waiting for the right moment to reveal itself. We are learning to listen more carefully than ever before, and what we hear could change our understanding of volcanoes and the restless Earth forever. How do we detect ground movement of mere inches, or even earthquakes too faint for humans to feel? The answer lies in a remarkable array of scientific tools, each designed to sense the subtle signals of our shifting planet. With the tools of modern science, we can observe the Earth in ways never before possible, capturing data from the surface and deep below. Permanent GPS stations, anchored firmly in bedrock, measure ground shifts down to fractions of an inch, tracking even the slightest movement over time. Seismometers, Earth stethoscopes, detect vibrations smaller than an atom, mapping tremors deep below the surface, and alerting us to the planet's hidden activity. Satellites orbiting high above use radar to scan the land from space, providing a bird's-eye view of changes invisible to the naked eye. INSAR technology, using radar images taken at different times, reveals subtle changes in elevation, showing how the ground rises or falls over weeks, months, or years. By combining GPS, seismometers, and satellite data, scientists build a multi-dimensional dynamic view of the volcano's behavior and its evolving landscape. It's like a doctor using multiple tests, X-rays, MRIs, blood work, to diagnose a patient, each tool adding a vital piece to the puzzle. No single tool tells the whole story, but together they reveal the hidden workings of McDermott, painting a fuller picture of what lies beneath. We can track magma movement, measure underground pressure, and listen for the cracking of rock as the Earth shifts and strains. These tools turn whispers from the deep into clear scientific understanding, transforming uncertainty into knowledge. With every new measurement, every data point, we get closer to decoding the language of our restless planet, learning to read its signs and signals. This is how we watch a giant awaken, through the eyes and ears of science, always listening, always learning. The force behind McDermott's stirring is magma, molten rock formed deep in the mantle. As it rises, magma can pool in vast underground reservoirs called magma chambers, the heart of a volcano. These chambers aren't simple caverns, but complex regions filled with molten rock, crystals, and gases. The size and depth of a chamber determine a volcano's potential. A deep, growing chamber can set the stage for a super eruption. At McDermott, new magma appears to be accumulating, perhaps forming a new chamber. Gases trapped in magma are key. When pressure drops, they expand, driving explosive eruptions. Scientists use seismic waves and gas analysis to map and study these chambers. By understanding the magma chamber, we learn a volcano's history and glimpse its future. The heart of McDermott holds the secrets to its next move. McDermott Caldera is part of a rare club, supervolcanoes capable of eruptions thousands of times larger than any in recorded history. Its most famous sibling is Yellowstone, just a few hundred miles east. Both are part of the Yellowstone Hotspot Tract, created as the North American plate drifted over a stationary mantle plume. McDermott's eruption 16 million years ago was one of the largest in the chain, leaving behind vast ash deposits and the nation's largest lithium reserve. Comparing McDermott and Yellowstone reveals the life cycle of supervolcanoes: violent birth, long dormancy, and possible reawakening. The new activity at McDermott challenges the idea that these giants are finished once the hotspot moves on. It suggests ancient systems can reawaken, forcing us to reconsider the hazards of extinct calderas worldwide. In geology, time is long, and what seems finished may only be sleeping. The story of McDermott and Yellowstone is still being written. The renewed activity at McDermott Caldera is not cause for panic. Super eruptions unfold over immense timescales. What we see now is the earliest hint of a process that could take millennia. So why watch? Because understanding our planet is our responsibility. Monitoring McDermott teaches us how volcanoes work, how continents change, and how to anticipate the future. Each data point is a new page in Earth's biography. Lessons learned here help us forecast eruptions elsewhere, protecting millions who live near active volcanoes. By studying subtle signals, we improve our ability to give timely warnings and save lives. The story of McDermott is one of curiosity, discovery, and our enduring quest to understand the world. By listening to these sleeping giants, we ensure a safer, wiser future on our ever-changing planet.